Welcome back to STS. In today's video, we need to prove that these two sides of this equation with these trig functions are congruent. First thing I notice here is that this denominator, 1 minus cosine x, is very similar to one of my trig identities. And that identity is sine squared x plus cosine squared x is equal to 1. If I solve this for sine squared x, I end up with sine squared x is equal to 1 minus cosine squared x, where all I did was I subtracted the cosine squared x value from both sides of this equation. So this denominator here is very close to that. So what I know I can do based off of knowledge in algebra, I know I can multiply by the conjugate. And in this case, that conjugate is going to be 1 plus cosine x. And that's what I'm multiplying the numerator and denominator by, which basically is another way of just multiplying by 1. And conjugate is just a big word that says all I'm going to do is take these two expressions here and change the sign in the middle. It started off as subtraction, I made it addition. If it were addition, I would have made the subtraction. So now at this point, I'm going to multiply what I have on the right hand side. So on the right hand side of my equal sign. So I have sine x times 1 to give me sine x, plus sine x times cosine x to give me sine x cosine x. For my denominator, this denominator with the conjugate, I know that all that I need to do is square the first term, which is going to be 1, and square the second term, which turns into cosine squared x, and I need to take the difference of that. So this here is going to always be negative. This is a fact that happens when you multiply by the conjugate. Now, at this point that I have that in place, let's go and continue here. This numerator stays the same, sine x plus sine x cosine x. And now for the denominator, I have that 1 minus cosine x squared. I see that can be interchanged with sine squared x. So here I place in the sine squared x. And now at this point, I'm going to separate this singular fraction into two separate fractions. So this turns into sine x over sine squared x, plus I keep this part of my numerator, sine x cosine x, again over the same denominator, sine squared x. And now I'm at a position where I can do some simplifications. I have one sign at the top and two signs at the bottom of my denominator, so that means this sign here cancels out all the way, and this sign here actually just becomes sine to the first power. On the right hand side, I have a similar situation. One sign at the top, two signs at the bottom. Because these are factors, I can do the simplification. So sine x cancels here, and I just have a sine x at the bottom. So when I rewrite, and matter of fact, let's put the rewrite here. I have 1 over sine x plus cosine x over sine x. Now I see that I'm almost where I need to be, where I've got the sine x in my denominator. I have a 1 here, and I have a cosine x here. I know that I can rewrite these two fractions as the same fraction because they share the same denominator. So this here becomes 1 plus cosine x over my denominator, which is just sine x. So here I've proven through these manipulations that these two values of sine, these two trig equations or expressions in trig come out to be the same value. That sums it up for this video by Speller Tutorial Services. Please friend us on our Facebook and subscribe to that YouTube channel. And as always, thank you for watching.